In this video, I'm going to share with you some of the science stories that didn't make the headlines but are absolutely worth paying attention to. I'm Philip, and this is the Space Missions Report. Today, we're going to be having a look at 3 of our flagship missions in orbit and looking at the science that they've been doing behind the scenes. In a recent study using NASA's Chandra X-ray observatory, scientists have confirmed that a tail of hot gas is trailing behind the galaxy group NGC 4839. It is the longest ever observed, measuring 1.5 million light-years in length. As NGC 4839 moves towards the center of the Coma galaxy cluster, the hot gas in the galaxy group is stripped away and superheated, forming an extended tail. By analyzing the gas in front of the galaxy group, researchers found a shock wave, indicating that NGC 4839 is traveling at about 3 million miles per hour towards the Coma galaxy cluster. They also observed a mild amount of turbulence in the tail's gas and possible evidence of Kelvin-Helmholtz instabilities, suggesting a sharp gradient in viscosity in the gas that creates vortices like the Great Red Spot on Jupiter or hurricanes on Earth, but at a much greater scale. The length of NGC 4839's tail provides an opportunity to study the physics of the gas before it merges with the gas in the Coma cluster. The study enhances our understanding of galaxy cluster formation and dynamics. Using NASA's Hubble Space Telescope, astronomers have discovered evidence for the presence of an intermediate-sized black hole in the closest globular cluster to Earth, located about 6,000 light-years away. Black holes generally come in 2 sizes, small and supermassive, but the intermediate mass black holes, weighing between 100 and 100,000 solar masses, have remained elusive. Previous observations identified potential intermediate mass black holes in other galaxies and globular clusters, but more data is needed to confirm these findings. The recent study focused on the globular cluster Miser 4, or M4, using Hubble's precise measurements. To quote the lead author, Eduardo Vitrol of the Space Telescope Science Institute in Baltimore, Maryland, "You can't do this kind of science without Hubble." By studying the motion of the stars caught in the cluster's gravitational field, astronomers were able to model the motion of the stars they could see and calculate the mass of the possible intermediate mass black hole of around 800 solar masses. The data collected by Hubble rules out alternative theories and suggests the presence of a concentrated mass that is too small to be explained by other objects such as neutron stars or smaller black holes. However, Vitrol cautions, while we cannot completely affirm that it is a central point of gravity, we can show that it is very small. It's too tiny for us to be able to explain other than being a single black hole. Alternatively, there might be a stellar mechanism we simply do not know about, at least within the current physics. Using NASA's James Webb Space Telescope, an international team of astronomers led by Texas A&M University astronomer Justin Spilker has detected complex organic molecules in the most distant galaxy ever observed. The discovery demonstrates the capabilities of Webb in understanding the complex chemistry associated with the birth of stars in the early universe. The galaxy observed shows an Einstein ring caused by a phenomenon known as gravitational lensing, which occurs when 2 galaxies are almost perfectly aligned from our perspective on Earth. Gravity from the galaxy in the foreground causes light from the background galaxy to be distorted and magnified, like looking through the stem of a wine glass. According to Spilker, by combining Webb's amazing capabilities with natural cosmic magnifying glass, we were able to see even more detail than we otherwise could. The organic molecules found in the galaxy, which is now over 12 billion light-years away, resemble smoke, soot, and smog that we are familiar with on Earth. The findings challenge the notion that the presence of such molecules indicates star formation, as has been previously thought. The Webb telescope's high-definition images reveal regions with smoke but no solar formation and others with star formation but no smoke. This milestone detection opens up new possibilities for understanding the early universe and exploring further galaxies to unravel the relationship between smoke and fire in the early universe. If you'd like to find out more about black holes and get an in-depth dive into how they work, check out this video from PBS Spacetime. For more of the science that happens between the headlines, don't forget to hit the subscribe button and ring the bell so that you're notified every time we drop a new video. Till next time, keep looking up.